Hello, everyone. So before Thanksgiving break, we were solving systems, and that's what we were doing when we did the word problems the past couple of days. So what we're going to do now is solving systems of inequalities. So the solution of a system of inequality is the set of all ordered pairs that satisfy both inequalities. So if we graph the inequalities, we're in the same coordinate plane, the solution is the region where the graphs overlap. So to solve the systems of inequalities, y is greater than x plus 2, I graph y is greater than x plus 2, which is a dotted line, and I shade it above. And then I graph y is less than or equal to negative 2x minus 1, which is a solid line because it's equal to, and that's shaded to the left. So the area of overlap is where our solution is. The lines are the boundaries. So that's what borders the area. So now example 2, here again I graphed both equations, or inequalities I should say, and x plus y is greater than 4 is over here on the right, and x plus y is less than 1 is over here on the left. And when I look at that, there is no area where they are share, so there is no solution. So let's practice doing this. So the first thing I want to do is I want to graph. So to graph y is greater than negative 2x plus 2, I need to graph the line y equals negative 2x plus 2. So that has a y-intercept of 2 and a slope of negative 2. Down 2 over 1, down 2 over 1, down 2 over 1. Do some backwards. Now I look back at my inequality and it's only greater than. That means when I draw the line through here, it's a dashed line. And now I need to decide where to shade. So to decide where to shade, I always pick a point. I pick 0, 0 if it's not on the line, and I substitute. So it's 0 greater than negative 2 times 0 plus 2. And that's false because 0 is not greater than 2. So I'm going to shade away from 0, 0. And this over here in blue is my first inequality. Now I'm going to switch to red, and I'm going to graph the second one. So to graph the second one, the equation is y equals x plus 1. So that has a y-intercept of 1 and a slope of 1. So that's up 1 over 1. I get these points. And equal to is part of that inequality. So I'm going to use a solid line. And then again, I'm going to choose 0, 0. So 0 is less than or equal to 0 plus 1. 0 is less than or equal to 1. So I'm going to shade towards the origin from the red line. And my solution area, so I label this inequality first. My solution area, which I'm going to label with an S, is over here where they overlap, where there's red and blue. Now, it's important to remember that when I'm on the dotted line, that is not part of my solution. On the solid line is, dotted line is not. So I want you to pause, and I want you to graph 2, 3, and 4, and then come back and check. Okay, so hopefully you paused and graphed these. So the first one, y is less than x plus 1, is my blue line, which is a dotted line because it's not equal to, and I shaded towards 0, 0 because 0 does work. The next one, 3x plus 4y is greater than or equal to 12. I solved for y, and while I was doing that, I pretended it was just equal to. So that has a slope of negative 3/4 and a y-intercept of 3. So I plotted that red line, which is solid because it's equal to, and I shaded away from it. So the solution area is this area over here. Number 3, again, I needed to make them y equals 2. So the blue line is my top line. I subtracted 2x from both sides. So that has a y-intercept of 1 and a slope of negative 2. And it's a solid line because it's equal to. And when I substituted in 0, 0 is false, so I shaded away from the origin. The red line, again, I pretended it was equal to solve for y, subtracted x, divided everything by -1, y equals x plus 2. That's a y-intercept of 2 and a slope of 1. It's a solid red line because it's equal to, and I shaded towards 0, 0. So the solution area is where the red and blue overlap. Last, number 4, the blue line is my top line, which shaded towards the origin. The red line's the bottom one. It has a slope of y-intercept of -1 and a slope of 2 shaded away. So the solution area is this area in between the two lines. So now we have a couple of word problems to look at. In real-world problems, sometimes only whole numbers make sense for the solution, and often only positive values of x and y. So example, AAA Gem Company produces necklaces and bracelets, and in a 40-hour-a-week, the company has 400 gems to use. A necklace requires 40 gems, and a bracelet requires 10 gems. It takes 2 hours to produce a necklace and requires 1 hour for a bracelet. How many of each type? So we let n equal the number of necklaces and b equal the number of bracelets. Now, because we're talking about necklaces and bracelets, that tells me right away that both of those have to be greater than 0. Now, using the fact that in a 40-hour week, I make bracelets and 2n is less than or equal to 40. And it's 2n because it takes longer to make a necklace than it does a bracelet. And then as far as gems, it's 10 per bracelet and 40 per necklace. And I can only have less than or equal to 40 and 400. So then I graph those. And when I graph them, you see over here on my graph that the defining factor really is the gems, not so much the time. So a solution is anything that's within the shaded region there. So 520 could be a possible solution. So now let's do one together. So I want you to pause and I want you to think about the equations for 5 and 6. And then come back and we'll check and graph. Okay, so Mr. Flowers is on a restricted diet that allows him between 1,600 and 200 calories. His dairy fat intake is restricted between 45 and 55. What daily calorie and fat intakes are acceptable? So I'm going to kind of view this 1,600 to 200 as the x needs to be greater than or equal to 1,600, and x needs to be less than or equal to 2,000. X equals is vertical lines. So when I think about graphing that, I'm going to do a vertical line right at 1,600. I'm kind of close to the 1,500 there. And it'd be to the right. And the 2,000 would be this vertical line. And I don't want an arrow on the bottom there. And it's the space in between. So that's his calories. Now, as far as his fat grams, that's y equals. So y needs to be greater than or equal to 5, and y needs to be less than or equal to 55. So 45 is here, 55 is here. So it's this area. So the area that he can actually eat is this right here. That little box is the acceptable range. So now, Maria had $150 in gift certificates to use a record store. She bought no more than 20 recordings. Each tape cost $5.95 and each CD cost $8.95. How many of each type did she buy? So they have tapes on X, so I'm going to say X equals tapes and Y equals CDs. So I have no more than 20. So that means X plus Y is less than or equal to 20. Now, as far as money, $5.95 per tape, so that's $5.95X plus $8.95Y. And she has to keep it under the 150, so it's less than or equal to 150. I'm going to graph both these using my intercepts. So here, to find the x-intercept with x plus y is less than or equal to 20, I put 0 in, so it's x equals 20. Put 0 in for y. Then I put 0 in for x, and I get y equals 20. So that's my intercepts. So 20 there and 20 there. I'm going to use a solid line because it can equal 20. And then it's less than or equal to. So that means 0, 0 does work. So that's this blue area. The other equation, again, I'm going to use my intercepts. So to find the x-intercept, I make y equals 0. So it's 595x equals 150. Divide both sides by 595. And x equals 25.21. So that's my x-intercept. Find the y-intercept, I make x be 0. So that's 895y equals 150. Divide both by 895. And I get 16.76 more. But I'm rounding. So I get that as my y-intercept. So I connect those. Ooh, that's not a very good line. Let's use the line tool. And there we go. And that she also needs to stay under. So that's this area. So the solution area is really what I'm kind of outlining here in purple. How many of each might she have bought? So I'm just going to look in that purple area for a clean point. So I'm going to say 10 tapes and 5 CDs. You could choose any point in that purple area.